Derivatives by Sama, Gabriel, and Karina.
So for derivatives, we have three notations. We have the f prime of x, the y prime of x, and the dy over dx. The apostrophe indicates prime. And then for here, if we wanted to break this down, we have the d over dx, which is the operator for the derivative, and then this would be d over dx of y, and y would be the function. So, for derivative, a derivative is the instantaneous rate of change at a particular point on a function. So, in this graph, with this point, it would be the slope of this point right here. It's the slope of the tangent line. So, it only touches the function at one point, and then it would be the slope of that tangent line that was just drawn. So, in some examples, we have the derivative of y equals 3 would be 0 because if we had this on a graph, the graph of this would be y equals 3, which is a straight line right here. And as you can tell by this straight line, the slope of it would be 0. So the derivative is 0. Okay, so then for polynomial, you have to take the derivative of each part. So we have y prime of it. We have y prime equals the derivative of x plus the derivative of 3. And so here, due to power rule, where you would just bring down the exponent and multiply it times the derivative of the, so then that would equal 1, and then as shown here, the derivative of the constant would be 0. So the derivative of this function would equal 1. And then the derivative of this function, we would do the same exponent power rule thing. So then we would have y prime equals 2x plus, so the exponent here is 1, so we would have, so we would have 2. And then whenever you do the power rule, you take the exponent down and multiply it by the coefficient, and then you take the power down by 1. So here, we took the power of this from 1 to 0, so it disappeared. And then here, we took the power from 1 to 0, so it also disappeared. And then the derivative of a constant, as previously stated, is 0. So the y prime is 2x plus 2, where we took the derivative of every single part of the polynomial. And then, to go deeper into power rule, we have a shortcut here. So the definition of the power rule is the derivative of x to the n equals n to the x over the n minus 1. So here, we took the power down in front and made it the coefficient. And then we subtracted 1 from the coefficient that we had. So in this example, we have the derivative of x squared. So we take the 2 down, make it our coefficient, and then we subtract 1 from this exponent that we have, getting us to 2x to the 2 minus 1, which gets us to 2x. And then, to show that this can be proved with the difference quotient, we have the derivative of x squared equals the limit of x plus h squared minus x squared over x plus h minus x. So we use the limit here because it's instantaneous, and the h represents the distance between the 2 points. So the points are getting closer and closer together, as we can see by the h is approaching 0. So then if we multiply this out and continue through, we see that we get the same answer that we got with our shortcut right here of 2x. So to go in more depth on how to do the exponential derivatives, we have to take the same approach of breaking it apart. So here we would do y prime equals the derivative of e to the x plus the derivative of 6. And then we previously learned that this equals 0, and then this is where we learn that the derivative of e to the x is very convenient and equals e to the x. So y prime, or the derivative of this, equals e to the x. And then we can do the same approach for this one, where we break it apart. And then, except for this one, we have the derivative of e to the 2x. And we consider, what do we do with that? Well, so we do the same thing, where we have y prime equals e to the x, e to the 2x, and then we take down, and then we take the derivative of what e is being raised to. So it would be 2e to the 2x. And then we have to continue breaking apart this part. So we have plus the derivative of x squared plus the derivative of 7. So then we know from the power rule segment that this part is 2x. So that is how you do the exponential components.
Don't forget to like and subscribe to the channel. If you have any requests or video ideas, feel free to comment down in the section below, or you can contact us via our email address provided by our YouTube channel.